Thanks, Scott. Glad to be here. Okay, so just want to make sure I'm coming through loud and clear.
Yes, you sound great.
Okay, perfect. Good. So let me just get our slides here. Good. Right. Hi, everyone. Thank you for joining today's EcoCast. And I wanted to tell a little more than just enterprise storage, because it will be unfair to omit other things we're doing. You need to get a little broader picture to see where enterprise storage fits in our product line and our ecosystem. So it's only storage side of the story this time, but there are multiple products in our portfolio which play together. So right now, the flagship product is the hyperconverged appliance, but we're not talking about it. It's not hyperconvergence. So next component is the HCA storage nodes. So these are storage-intensive controllers which can either play along in our hyperconverged infrastructure or can act as standalone storage, which can be used by the existing environment connected to anything, and we'll talk about it later. Then we do have our own software-defined storage stack, which is StarWind Virtual SAN, and it's getting more and more developed and starts to evolve into something which is not only storage but also management and DR part of the story. Then we have the HCA backup nodes, which act as a backup aisle within the cluster and allow for fulfilling the 3-2-1 backup rule, basically having your data safe and making sure that in case of a disaster, the data is easily recoverable. And finally, we have our cloud virtual tape library for AWS and Veeam, which allows customers to seamlessly transition from their tape-centric environment into a virtual tape-based environment. So we'll talk a little bit about all of these components today, mostly focus on storage, but just wanted to get a brief overview of what we're working on and what we have. Now, talking about the software-defined storage stack. Software-defined storage stack is the engine of most of our appliances, and a lot of features it offers are automatically inherited by all our solutions. Right now, it's not just multi-protocol storage, as you see. It supports all commodity protocols. So it's everything but fiber channel. So we even support NVMe over fabrics. We've just added it to the product. We do dedupe and compression on top of this. So with all these protocols, you can still get all the space-saving features. And we do support integrating cloud storage as a tier and as a replication destination for our storage. So just to give an idea of the capabilities for our storage. We originally started in a very interesting spot, which is making storage shared and fault-tolerant without additional dedicated storage hardware, and then it all evolved into separate concepts. So the fault tolerance engine we originally started with is designed to deliver high performance and real fault tolerance. So we not only synchronize the storage between the nodes in our cluster, but we also synchronize all the caches, which means if one node goes down, the second node doesn't only have full copy of the data, it also has preheated cache, and there is no performance drop if we fail over. As for the failover, it's completely regulated by the initiator side. So whatever accesses the storage, it always accesses it. using its own best practices. So for vSphere, they use their initiator, they use their multipathing rules. They fail over when they need it, not when we tell them to fail over. So VMware always has the latency best practices fulfilled. And with Microsoft, they get their best practices fulfilled. Now, when we scale beyond 2 or 3 nodes, we want to maintain highest possible resilience of our cluster. So when we add more than 3 nodes, we start building a grid. It works like this. We add 3rd node, but then we start just replicating data between our nodes, making sure that our fault domain does not increase. So unlike N+1 and N+2 clustered solutions where 1 or 2 nodes failure may result in complete cluster going down, we aim at maximum possible survivability, even in case 50% of the nodes go down, or if we lose more than that, the cluster will still be partially available. So still able to serve customers and applications which are replicated more than between 2 nodes will still be available. Now, there were several major updates within the last 6 months to the software-defined storage engine, as well as to our appliance line. And I just wanted to briefly run through some of them to give you an idea what we're working on and where we're going. First of all, we have added Swordfish management support, and we're now working very closely with SNIA to make sure we take part in talking the single and unified data center language for management, monitoring, and orchestration. Then we developed our own HTML5-based management and monitoring platform. And it's not just for StarWind, it's actually a true platform. So we have the APIs, we're publishing them, and people who want to add their functionality on top can easily do that. So for instance, StarWind already offers storage spaces direct monitoring features, so people who don't want to install the System Center Virtual Machine Manager for a graphical interface for storage spaces direct can use StarWind's management platform to do so. We're developing our own virtualization management, and effectively, by the end of this year, we plan to unify the entire StarWind cluster management, be it backup components, be it hypervisor components, or software-defined storage components, be it StarWind or not, can be controlled from just one place. So making it a true single pane of glass and not making it just work for us, but actually making it fully customizable for customers' real needs. We then have the extensions into public cloud, which are certified instances for Azure and AWS, for both site recovery and site replication, as well as individual virtual machine replication. NVMe over Fabric support, this is for those folks who are IOPS hungry and want more than millions of IOPS in their environment. So we're already working with 100 gigabit networking and making sure that RDMA enabled NVMe over Fabrics is available for our customers so they can start getting the gist of the new technology, as it will definitely find its place in the data center later this year. And as we see more and more development in the flash technologies, especially Optane 3D Crosspoint, more people are gravitating towards NVMe over Fabrics. Another addition which kind of went under radars for a lot of our users was the vCenter plugin. It was actually included in StarWind, but we didn't make a big buzz about it. Not sure why, but just wanted to mention it here. Combined with existing vVol support, we make StarWind management completely invisible and fully automated for vSphere users. So they just predefine the policies they want based on resiliency and performance requirements. And after that, they don't really even need to see StarWind. They just need to plug in to monitor it from time to time, and the rest will be done behind the curtains. And finally, a major overhaul for our support is the addition of proactive support and monitoring services. I'll talk a bit about it on the next few slides. So with proactive support, we changed the way support works. It's not the customer who needs to chase support. It's actually support who tries to call the customer when he's on vacation or when he's drinking beer with his friends and saying, guys, can you just give us remote access because there is something bad about to happen in your infrastructure and we want to prevent it. So with traditional support, you chase the engineers and you wait to hear from them. Let me see if I can make these animations work here. Okay, yeah, now we're rolling. Sorry. So first something happens, then admin gets a notification, or he gets a notification from his users saying that there is something wrong with our infrastructure, something not working for me. He tries to find the root cause of this issue. Then he narrows down that, okay, that's probably a drive, or that's probably a switching problem. Then he submits a ticket to support and waits for support to get back to him. And then we go through the standard support process. Give us the logs, please. Maybe we need to involve third party because it's not the problem with storage. We've heard that a lot. And then eventually we come to a resolution. So we really wanted to get away from this, making IT administrators' lives easier and save them tremendous amounts of time on monitoring and constantly trembling over their infrastructure. So with proactive support, we get what's called a failure pattern. So an issue is about to appear. Let's say we have increased latency, or we have certain problems on the disk side. And we got a notification. StarWind gets the background of the issue. So it looks at what has happened before. Has something like that happened before? Are there any definite symptoms to cause a serious failure? Then if it's something that is not related to StarWind, we can involve the third party to help with that. Then we reach out to the customer saying that we need access and we need to help you. And finally, we resolve the issue. So in our case, with proactive support, customer gets a call saying that, sir, please pull over. You're about to have a flat tire. So wait till someone comes out to help you. Now, another product we recently added to our portfolio is the Cloud VTL for AWS and Veeam. We have just launched this product at VeeamON, and there are already a lot of companies who have enjoyed it and replaced their tape-centric environments with either our software solution or our hardware solution. Some of them are still in the middle of the overhaul and use physical and virtual tape at the same time. But, so how it worked before with physical tapes? We've got our IT infrastructure, we got tape backups, let's say every night or every week. We then have to physically ship the backups offsite. We have to maintain, manage everything on the physical level. there is a lot of manual work, labor involved in this process. And also there is the fact that tapes need to be properly stored so they can then be restored. So it's really not a process which can be fully automated. And it's also a process which at some point starts affecting the production environment because the backup window cannot be extended. Infrastructure needs to work 24/7, and the shorter the backup time, the better the performance, the less the effect on the infrastructure. So what does StarWind Cloud VTL change in this equation? We get rid of the physical tape library. We replace it with a virtual tape library, which acts according to the same backup policies customers had before, emulates a traditional physical tape library, but the moment when Veeam ejects the tape, StarWind's virtual tape library either tiers or replicates that tape from on-premise to Amazon S3 or Glacier. And we can also keep local backup copies, and we can keep multiple copies, or either in S3 or in Glacier, to make sure we fulfill that 3-to-1 rule. As you can see, there is no manual labor involved at all. Everything's completely automated, and everything is really flexible. So for each tape, we can configure retention policies for the on-site copy, for the S3 copy, and for Glacier storage. So we can either replicate immediately after tape is ejected, or we can keep it local for a day or two, or we can just never replicate it. The same goes for the S3 and local copy. It can be either immediately deleted to save local storage capacity, or it can be held for a few days and then removed after that. Ultimately, the idea is to get the tape-centric backup infrastructure to work as it's supposed to work in the 21st century. And there are at least 7 reasons to rethink tape backup if organizations are still bound to their tapes due to regulatory environment or just huge investments they already made in it. So I will just go through these 7. So first of all, with virtual tape, we can parallel the jobs. So even if we back up a lot, everything can fit into the backup window. We can emulate as many tape drives as we want. So it can be 100, and it will still take just 1 unit of the server rack space. Then with virtual tapes, we don't necessarily need to back up and move entire, let's say 2, 3, 5 terabytes between on-premise and the cloud. We can customize the tape size down to the individual virtual machine or even individual database. As mentioned before, all processes are fully automated and unmanned. And also, we can set up the cloud tiering and replication the way that there is no user access for AWS. So there is no need to type in the password, and the AWS storage for the tapes can also be completely segregated from other AWS infrastructures running in the company. Then another major advantage is tapes ransomware protection. So ransomware cannot talk tape, at least for now. And if ransomware starts talking tape, this is where Amazon Glacier's speed becomes its advantage. So by the time ransomware tries to pull the tape back from Glacier, admin can cut all access to the vault and leave the data intact. Also, another thing about virtual tapes is lower operating expenses. So no dedicated staff need no more cleaning tapes, and there is even more to that, because in the long run, cloud storage only gets cheaper, and the virtual tape library format lasts decades. So let's say for large organizations who need to store the data, let's say hospitals who need to store the data for the lifetime of their patients, they don't need to store multiple generations of tapes. I mean, in 2050, they can pull up the same virtual tape image, restore, and get the data readable. So there is no need to find that old LTO3, LTO2 drive to get the old tape and read the data. It's all much simpler now with tapes being virtualized. And finally, there are several announcements we're going to make later this month. We are launching our new product at VMworld Las Vegas this year. And I'm now giving just a little bit of information on what it's going to be. So there is a major ecosystem plan for our storage. We originally started with just software-defined storage and StarWind being self-sufficient in this equation. But what we wanted to change is to use our multi-protocol capabilities and our features to combine them with other parts of the puzzle. So in our case, on VMworld, we will be releasing a petabyte scale enterprise storage appliance. And we added some of the information about it into the handout we're giving during the EchoCast. So be sure to download that PDF to learn more about what it's going to be. But the main idea is that we are completely disrupting the enterprise storage architecture by scaling the node size down to the size of the individual drive and basically using, I would dare to say, disposable components to build massive scale-out clusters, which are Ceph and StarWind backed, where Ceph handles the massive scale-out and StarWind handles making sure the performance is great and making sure it can work with any solution on the market and provide protected multi-protocol storage to it. So in the diagram here, we illustrated the support we're going to add to StarWind. I already mentioned the massive scale-out Ceph backend. So we already developed our own hardware, which we are going to be presenting during VMworld. And we are also adding support for either our own NVMe over Fabric's backend added to StarWind controller nodes or using Intel SPDK and VMEF engine, as well as adding support for legacy storage. So all this would be brought together and centralized management on the StarWind side will make this available to all commodity hypervisors, as well as Veeam for direct access. Okay, I think that's all for today's presentation. Sorry I didn't get the chance to talk more about the enterprise storage appliance, but stay tuned, subscribe to our Twitter channel, and we are starting to share all the information at August 28th around 3 p.m. Eastern time. So stay tuned. And I guess now it's questions time.
It is. And we're going to, we have a few questions for you, Max. The first one actually is a hello from Henry Yao at Power Gilbert. He wanted to say hi to Max. And the question he has is, hold on, this is not a good one. And you may have answered this in the presentation, but do you support KVM?
So we're currently working on KVM support. As for dedicated storage, yes, we already support KVM, but we're also working on KVM support in our hyperconverged infrastructure.
What about deduplication and compression features? Is that incorporated, or is it an additional license that is necessary for the solution?
So it is actually our in-house developed solution. So it's included in the appliances or software by default.
Perfect. So the question goes, we use a lot of third-party applications that are installed within their Citrix environment, such as Dropbox, IQ, and various legal software. Can these disposable components handle these?
Yes, because disposable components are used for capacity scaling. So the idea is we have multiple nodes, and the node is comprised of an ARM chip and a single hard drive. And then SAF puts these all together as a single namespace, and StarWind adds NVMe and flash caching on top of that. So we can easily handle that, and I'd say almost any workload can be handled like that, because we can effectively configure what proportions of spindle and NVMe and flash are used for handling a particular workload.
And just for the audience, I've put the next poll question live for you, so you can see that. If you'd like to answer that for us, that'd be great. And Max, I believe this is more of a comment than a question, but it sounds like the person's basically validating StarWind really has a solution that spans the gamut. It's relatively easy and fast and safe, and it's good for SMB, small medium business, flash, hybrid, and even cloud and hyperconverged storage.
So I'm not sure which part of it is the question, but I guess
I'm not sure either.
Yeah, so basically, yes, we do have components which play well in in all of these areas. So SMB, yes, our hyperconverged appliance is really loved in the SMB and enterprise robo space, because we start with just 2 nodes and we allow both scale out and scale up. So they love us for that. For Flash, we added NVMe over Fabrics, and we already support 40 gig and 100 gigabit RDMA-enabled protocols like ICER. So Flash is also well covered. Hybrid environments, so let's say the enterprise storage appliance I just mentioned is an interesting example of the hybrid storage, where we have technically capacity blades and controller nodes have replicated cache and metadata for them. Full cloud, there are certified instances in Azure and AWS. And just storage, well, storage is our DNA. We started doing iSCSI in 2003, actually when the protocol itself appeared. So, yeah. I'm not sure I answered it, but I did the best I could.
I remember using StarWind way back when, your iSCSI target software. It was to turn a Windows machine into an iSCSI target. It was really awesome.
Yeah, and we recently got a guy who came back to us asking for a license after 8 years of constant uptime. And the guy said, yeah, we still use version 3.5, where it was already version 8 on our end. So we're like, wow.
Did you give him a license?
We gave it out for free, just because the guy
was...
Did you
really? That's a loyal customer, isn't it? Max, that's all the questions we have today. So thank you very much for being on today's EcoCast. We always like having StarWind. You guys are doing some really cool stuff in the storage space. Thank you for being here.